Hello and welcome to our F5 lecture recap number 16. This was on a budgetary analysis, a little bit more analysis to add to what we did last time. So we'd already removed the trend last time by using our moving averages or identified the trend. This time we want to look at the seasonal variations. So there's two ways to look at this. First of all, the additive model. What this does is it uses the formula y equals t plus s plus r. Y in this is our actual series, so for example our sales figures. T is the trend that we were calculating using our moving averages last time. S is the seasonal variation that we are particularly interested in this time. And R is our random variation, so those unforeseens that we can't predict. So how do we use this additive model? Well, what we do is we're looking for our seasonal variation. Keep coming back to that. We're looking for the seasonal variation. What we're going to do first of all is assume that R is 0. Why are we doing that? Well, we can't predict R, it's random. So it's going to be very difficult to bring into our calculations, our forecasts. So let's just assume that it's 0, i.e. let's just ignore it. So leaving R out of it, we have y equals t plus s. So what we're saying is that our sales are made up of our trend, i.e. how much they're going up generally, and S, which is our seasonal variation. So our sales figure will include the trend and the seasonal variation. If we flip that round, we get S equals Y minus T. So we're looking for our seasonal variation. Our seasonal variation will be our actual figures less the trend figures. So what we're going to do is calculate the trend using our moving averages that we did last time, and then we're going to remove it from our sales figures. And what that will do is leave us with our seasonal variation. So let's do that. Looking at the example we have here, we have our sales in 05, 06, 07, quarters 1 to 4. We've done our 4-point moving average like we did last time, got our trend by taking the midpoint. And what we have is then we've removed the trend from our actual figures to get our seasonal variation. So looking at the first one there, we have in quarter 3, 420 of sales. Our trend is 650. 420 less 650 is minus 230. So looking on down to 2006 quarter 3, again we see that it's minus 249.25. Now that'll be expected because what we're starting to identify is that in quarter 3 there's some sort of seasonal variation that is bringing our sales down, and that's what we're trying to identify. So to look at that more detail, what you do is get it into the different quarters. So flip your table around, get it into the quarters to see if you can identify what the seasonal variation is. Now obviously it's only going to be a seasonal variation if it happens all the time. So what we do is we take our quarters, quarter 1, 2 and 3, and we sum them and take the average, because that will get our average seasonal variation, which will be more accurate than taking just one figure on its own. Now what we do find is that this should all add across to 0, because obviously we're just seeing how that seasonal variation fluctuates around the trend. So the total of it actually comes across to 8.75. So if we add across our averages, we come to 8.75. We need to take that away, so turn it into 8 minus 8.75, share it out across those averages to remove it. So if you go to the bottom line, the 20.313, 203.067, etc., that will add across to 0. All we're doing is making sure of that by taking that, sharing out that 8.75. So don't worry too much about that. Do be aware of how to calculate these, but do be aware that they usually will give them to you in the exam. They'll give you the seasonal variation. So if you are given the seasonal variation of minus 20, 203, minus 241, how do you use it? Well, you'll forecast your sales figure maybe using the moving averages and adding the trend. But then you'll have to take away or add your seasonal variation to say, well, okay, quarter 1 we expect these sales, but we need to remove that 20.313 for the seasonal variation that we expect. So remove that seasonal variation in the exam questions. The second way to do this is the multiplicative model. Now it is y equals t times s times r. Now it's exactly the same. Again, if we say r is naught, then y equals t times s. This time our seasonal variation then will be our actual figures divided by the trend rather than subtracting it. So we do exactly the same. We'll find that we come up with figures around 1, so slightly less than 1, slightly more than 1. And what we do is we use that the same as we did with quarter 1, 2, 3 and 4. Again, this time it should all add across to 1. If it doesn't, we need to share out that difference to make sure that it adds across to 1. And this time, if you were given that variation in the exam, you would multiply your actual results by it to add in your seasonal variation. So rather than adding, you would multiply it. Okay, we then said a little bit about using these seasonal variations. Remember, if we're forecasting, we'll use the trend. So if we have an upward trend of 3% per quarter, to forecast, we'll say, right, add in 3% to each of the next 4 quarters. Remember then after that, you'll add or subtract your seasonal variation to remove that. The problems we might have, well, the future's unpredictable. The future is unpredictable, so forecasting anything can be difficult. Remember that you're using historical data, which may not necessarily be a reflection of the future. And we have ignored those random events. So if you think of the financial crisis at the minute, no one predicted that, but it's having a massive effect. Any predictions that you'd have made before then wouldn't be accurate now. And also any predictions involve the use of judgments. So that was our session on a little bit more analysis.